Hello all, I'm Konstantinos Costa from University of Pittsburgh. I'm very excited to present our system CAPRIO version 2.0, a context-aware unified indoor-outdoor path recommendation system. The motivation behind this work is to enable navigation to consider the indoor or outdoor context. With the indoor or outdoor context, we are referring to weather conditions, natural disasters, and pandemics. Especially now with the COVID-19, with over 2 million cases in US, we want to minimize or avoid specific sections of a path. The second objective is to recommend paths that satisfy the accessibility constraints. 32 million adults in the US have some form of mobility disability. Existing navigation and localization systems are primarily focused on outdoor or indoor localization and navigation, and only some of them are using outdoor and indoor information at the same time. And those are only focusing on the seamless transition between the outdoor and the indoor navigation. In contrast, our system supports a multi-objective context-aware path recommendation. With the context-aware, we are talking about accessibility, indoor congestion, outdoor exposure, and distance. Just to give you an idea how our system is working in an abstract way, consider these buildings. These buildings are inside the University of Pittsburgh campus. We have multiple buildings, and we want to go from the Center Square to the Maple Square. If we request this to Google Maps, we are going to get this path, the green path back. But let's say it's very cold, we don't want to go outside, so we want to take into consideration the natural disasters and the extreme weather conditions. So our first initial CAPRIO version was taking into consideration the outdoor exposure, so we can get this path, the red path back. But let's say now we have an event at the Barcolo building where the red people are there. So the idea is that we have the COVID-19 right now. We want to avoid this event, the congested building. So our CAPRIO version 2.0 system is going to recommend a new path that avoids the congested area and provides an accessible path. Now let's go to see how the actual algorithm, the core algorithm is working. First of all, it's a three-step algorithm. The idea is to create a graph and initialize that graph with the outdoor vertices. For each one of the outdoor vertex, we are having an indoor accessibility graph. This graph allows us to eliminate non-accessible entrances or exits. The second step is to calculate the weights and assign each weight to an edge based on the user preference. So the idea of the weight is a summation of multiple fractions. Each fraction represents an objective. The objectives are the outdoor exposure, indoor congestion, and distance. After this step, we can have a linear scalarization. The idea is to minimize all the weights using a shortest path algorithm. Any algorithm can be applied: Dijkstra, Floyd-Warshall, and Belfort. Our architecture consists of 3 layers, and actually the initial architecture was very similar. The first one is a data layer where we extract, transform, and load the data. The second step is the processing layer where we have our core algorithm, the graph-based data integration. The idea is to integrate the indoor and outdoor information into one graph. And then we have the application layer where we have an intuitive UI and an open API. The main contributions of the new work is a congestion forecasting that is based on machine learning techniques, especially LSTMs, given the time and given a specific section of the path captured by our new spatial structure that give us the location of the predicted congestion in the buildings. And then we have the accessibility component that allow us to remove or disable non-accessible entrances and exits. Let's see our CAPRIO system in action. As you can see, our system is using a map interface. In the map interface, we have some of the buildings and some functionalities on the map. You can change the actual tiles of the map to more traditional look and feel, or use any tiles that you want. We have a button to find your current location. This will allow you to navigate through the path, and you can, of course, zoom in and zoom out. Just to give you the full idea of the buildings, we can enable or disable the actual entrances and exits of each building. So the blue markers are indicating the accessible entrances or exits, and the purple markers are the non-accessible entrances or exits. So if you think about this, you can imagine that we can create a graph around the buildings. Of course, now we need to select a path and destination and a source. We have the site query panel that has options about the source and the destination, some settings, and some contact information. For example, you can search about a specific building, or you can select it from the list, but it's easier to use it for finding the actual building on the map. So you can say, I want to go from here to here, and you are going to get a path. This path is from Google Maps. Let's go back to the query panel. So in the query panel, you can adjust the preferences of each objective. I want to have this outdoor distance and so much congestion. If you want to minimize everything, you want to put it in the minimal setting. Of course, for the congestion, you need to select a specific time step. In this case, let's select the time step at 9 a.m. and get the path from our previous version of CAPRIO. We call it CAPRIO S, that doesn't consider the actual congestion and the accessibility. So as you can see, we have a longer distance than the Google Maps, but lower outdoor exposure, of course, because Google Maps are outside. They don't take into consideration the indoor congestion, so we don't have a lot of congestion here. And our CAPRIO version 1.0, let's say, is having a lot of congestion. Now, if we want to add the congestion and the accessibility as objectives in our path, we are going to get a different path. Now, the actual path is going to different entrances to the exit and avoiding some of the congestion. This allows us to get a different path that is accessible and has a lower percentage of congestion. Of course, to visualize that, you need to see the graph. So the idea of the graph is that we have different weights, and you can visually see the actual graph. In addition of that, we wanted to have alternative paths, so you can enable the alternative paths to see if you have a different preference. Instead of going inside a building, let's say we want a different path. So we are getting the top K path. Uh, Thank you for your attention and your time. I hope that I trigger your curiosity to try CAPRIO version 2.0. So you can do that by following the link db.cs.p.edu/CAPRIO or scan the QR code. We will really appreciate it if you send us your feedback about CAPRIO and even ideas to extend CAPRIO. Thank you.